Hey friends, Dr. Borole is here. Today we are going to study a DC regulated power supply powered from AC mains. The block diagram of a DC regulated power supply is shown in the figure here. We need a DC power supply for powering the electronic equipment and electronic circuits as VCC and VEE supply. Normally that is in the range of 5 volt to 24 volt. Whereas we have a AC main source that is normally having the RMS voltage value in the range of 230 volt in Asian region and 110 volt RMS in European region. Therefore, we cannot directly rectify the main signal supply and convert it to DC and then connect it to electronic equipment. What we have to do is we have to first get the required lower voltage from the mains. That can be done by using the transformer. And therefore, first block of regulated AC to DC power supply is transformer. Normally, this transformer is a step down transformer. We have 230 volt RMS single phase 50 Hz AC supply that feeds the primary, and secondary voltage is lower than the primary voltage that can be chosen. Normally, it can be 5 volt RMS or 9 volt RMS or 12 volt RMS or 15 volt RMS and so on for electronic circuits. The transformer is a device which just transfer the power from primary circuit to secondary circuit without altering the frequency and wave shape of the power line signal. Therefore, if you see, if the primary signal shown here as Vm sine of omega t with the peak value 230 root 2, then secondary signal is also Vm sine of omega t with the peak value, say typically 15 into root 2. Wave shape is exactly same, only amplitude is change. The primary and secondary voltages in the transformer are related by turns ratio. The secondary voltage V2 by the primary voltage V1 is defined as the turns ratio equal to Ns by Np, where Ns is the secondary number of turns and Np is the primary number of turns. The next block is a rectifier here. Since we want the DC voltage and we have a AC voltage at the secondary of the transformer, we first convert this AC voltage into unidirectional DC voltage, and that can be done by a rectifier circuit. There are various types of rectifiers. Those can be used for this purpose. They are broadly classified as half wave rectifier or full wave rectifiers. Normally in practice, the full wave bridge rectifier is used. The output of the rectifier circuit is shown here. You will see that the output consists of a rectified input AC signal which is coming from the transformer secondary. This signal is no doubt a DC, but it is a varying DC. It consists of AC plus DC component. DC component is the component in which we are interested in, but the AC component, which is unwanted one. This AC component is also called as ripple. This unwanted ripple needs to be eliminated further. That can be done by using the additional block called filter. Filter is basically a low pass type of filter. Most popular low pass filter used here is a capacitor input filter or L section filter. The function of the filter is to eliminate or to filter out the ripple component and pass only the DC component at the output. If the filter is simple capacitor filter, then you will see that this capacitor will be charged to the peak value, and when the rectifier diodes are in the off state, the capacitor will serve the load and therefore you are getting the discharging of the capacitor. Whereas due to this action, you will see that the average DC value is passed at the output of the filter and ripple is much reduced compared to the output of the rectified signal from the rectifier. But still, there is a significant variation in the DC voltage here. Typically, say average DC value is 15 volt plus or minus 3 volt. In some electronic circuit, these variations are not tolerable, and therefore the voltage will be further regulated by using the next block called voltage regulator. The filter output is also called as unregulated DC voltage because this voltage also changes when the input AC amplitude changes and if the load current changes. Accordingly, the regulation terms for the total rectifier and filter circuits are somewhat poor, and therefore we add an electronic regulator circuit here whose function is to reduce the variation in DC. We can say that this regulator further reduces the ripple content which is present at the output of the filter to low value. The voltage regulator is a complete feedback control system which continuously monitors the DC voltage level at the output and correct the voltage across itself so that output will be maintained constant. For example, if input voltage changes at the input of the regulator, the output tries to increase. When it increases, the sensor system senses it and increases the voltage drop of the regulator by exactly the same amount by which the input to the regulator is increased so that output will be maintained constant. Second case, if the output voltage tries to decrease, the small change in the output is sensed by the circuitry and it will decrease the voltage drop across the regulator itself and try to pull back the voltage to the set value. And thus, the output voltage will be maintained constant by the regulator. If you see the output voltage waveform of the regulated output DC voltage, it is mostly a straight line at voltage VDC. In practice, this is not very constant, but still, typically this value is 15 plus or minus 50 millivolt. And for all of the practical purposes, this power supply is accepted to power the electronic circuit. This way, we can generate the DC power source from AC mains. That's all, friend. Bye bye.